All right, thanks, Dan. So I'm Brian Bockelman. I'm at the Morgridge Institute for Research, and I'm going to start off a little bit about the OSDF. Give me a second. Hopefully, everybody can see the screen. Looks good. Wonderful. So I wanted to start off by basically saying the whole presentation here is asking this question, how can we partner together? How can we work together? How can we provide value? I'll be talking from the OSDF side. How can we provide value to your CC project? A little bit about who I am and where I'm from. So I'm from the Morgridge Institute for Research, which is a private research institution on the UW-Madison campus. If you want to round off a little bit and say I'm from UW-Madison, it would only be a little bit wrong. But one really amazing thing happened actually this week, which is the computer sciences department on campus moved in right next to our institute. So uh, what I am part of the Center for High Throughput Computing, which actually spans both the Morgridge side and the UW-Madison side. My co-PI and co-conspirator is Maron Livni, and now we can actually take one lovely picture and actually capture both the physical presences of the center. The other thing that it'll come back to later, but it's really important in how we practice and advance what we're doing is this concept of translational computing or translational computer science. So the terminology was borrowed from maybe our friends in medicine, but this idea that we can advance our science better by practicing it in a certain locale. So for us, that means running services and building out communities that depend on the services. And where we advance is through the feedback that folks like, to be frank, the people on this call provide us. So uh, it's not that we're bored or particularly altruistic, but we're hoping that we can all work together because it ultimately, we believe, is the best way for us to advance what we do. So, what is it we do? If you ever, well, uh, try to work with scientific data, or even more difficult, be a PI and try to grow a community around your scientific data, it is a hard job. Right. In fact, for those of you particularly in the data set part of the solicitation, there's a lot to do to create, whether it's observe, simulate, curate, and put together a high quality scientific data set. But as most of us found out, that is nowhere near the end of the road. Once you have your well curated data set, as a PI, your work really starts. How do people access the data set? If it's not completely public data or you want maybe some usage statistics, how do you manage access control? How do you get the data set to where your community is for computation, where our great repositories are tend to be different, sometimes even different physical locations from where our computing resources might be. And then how do you even scale access to that data? There are some solutions out there. Everybody loves S3 up into the point of uh, paying for S3. So egress fees can kill if that's not where your community is, and your community does not love the user pays mode of S3. So there's a huge number of problems and building a community, growing around this little seed that NSF might plant, uh, that as a PI, it's a really broad set of skills. Um, so there's a couple ways to approach the problem. At some point, you can say, dear user, it's on you. I grew this data. I put it up on my university web server, my S3 bucket. I created a website. I told all my friends about it. You get to do the rest. Nobody provided me funding for compute. And you can figure out how to download the data. You can write the scripts. You can figure out what hard drive or NVMe device or shared file system that you put on and update it to make sure there's no corruptions and figure out how to scale your computing against it and so on and so forth. Which, it's a relatively inexpensive approach, but as we've all seen over the years, the higher the friction for users, really the smaller the impact of the data, even if it's wonderful data. Uh, you can flip it around and go the complete other side of the pendulum and say, we'll do this for you. We'll work to scale out a repository. Computer scientists love to see things that scale well. We'll build some tools. Maybe you've been involved doing gateways before, thinking about how do you do the authentication authorization and start tackling all these problems that pile up and making data usable. And the problem is at some point you run out of money, right? You have to, time is money and you have to actually do the science. And I'd say none of us are funded that well that we can do all this in-house. So as you can imagine, there's a third option, which is leveraging the investments that NSF has made out there in the ecosystem. So we're not just a handful of independent awards, but we all collaborate, leverage, and try to build on top of each other and our friends. While you understand your data set well, some of these problems are really common across multiple domains, which allows us to build out foundational national scale infrastructure. So I'll be talking about OSDF, which allows you to deliver data and move stream data sets around. Uh, LK is going to be talking about the National Data Platform, or NDP, which provides services more along cataloging, publishing, building bespoke services and environments for your community. And NSF funds computing platforms that allow you to explore and analyze the data. So I'll be talking a little bit about OS Pool and mentioning the National Research Platform as well. So by leveraging, you can kind of go in the middle between those two sides of the pendulum, or you can build the community, you can provide value, and you don't have to do it all yourself. So, what is the OSDF anyway? So, when I'm talking to a non-technical crowd, uh, I take the user point of view and I say OSDF is trying to be Netflix for science. We want to stream data to wherever the computing is needed for a particular scientific computation or visualization or for download. And have you ever had to go through Netflix training? Have you ever had to go through the long, big tutorial for how to use Netflix? No, the idea is almost just about anybody can use it. So from a user point of view, we want to make it easy to access, once you know which movie you want to watch, we want to make it as simple as hitting the play button for getting your computational workloads that stream data. Now, I said this is what I say for a non-technical crowd. This crowd, a little more technical and looking at some of the list of the participants here, I know we can go the next layer down. We might actually be closer to Cloudflare for science. So this is also the more infrastructure-centric way of looking at what you do. We build out a service, a network that allows you to scale access to your storage. So in the same way that your university might use Cloudflare to distribute its websites and protect it and manage its web services, we want to do the same thing for your scientific data. We want to allow whatever your repository that you have set up to scale through data reuse and to be protected against what I lovingly refer to as the enthusiastic grad student. So whether you take the user view or more the infrastructure view, you can kind of think of at least broad brush what we're trying to accomplish as Cloudflare or as Netflix. Uh, our center, just to give a broader picture, this is one of the services that we run. We also run the OS pool for computation, and we have a wonderful facilitation team for open science. So this all falls under the broad umbrella of the OSG Consortium and the OSG Fabric of Services, and a couple of interrelated software projects that I would really love to talk about yeah, maybe in a bit of a follow-up. But setting aside the broad things we do and looking just at the OSDF, so I mentioned it's a global service for data delivery. It's operated by the PATH project, which is an NSF-funded project. That's who runs the service, who monitors it, who wakes up every morning and looks at the daily reporting emails and says, was it a good day or a bad day? On the other hand, the software, the things that we compile and ship out that power the service are part of the Pelican project, which I'm the PI of. Then, in order to make this valuable, we have put uh, caches both across the nation and globally to replicate and make the data scale. And those leverage hardware from a variety of projects, including the NRP, Internet2, ESNet, several large computing providers within the US. Our goal is to get these in as many places that would be beneficial to the scientific community. Uh, and the OSDF, if you look at it in terms of data sets and repositories, looks like a content delivery service. So you have wherever you've stored your data. We've heard that too as the object store. Uh, we say object store, that might be evocative of, say, S3, but this can be a web server, this can be a POSIX file system, this can be a global scats collection. And we think of it as an object store and connect it to the rest of the service through what we call origin. So the origin is the thing that connects the data across and implements, say, whatever your access policy might be. So in some cases, the origin might be performing duties in terms of management and protecting in terms of IO. In other cases, it might be setting the authorization policy of, these 5 people can access it, but the rest of the world, no thanks. And then the rest of the services there in that little cloud are what we deploy across the nation to allow reuse and managing access. So just to give a little simple about my limit of PowerPoint animation skills of how this setup can look, let's consider this particular case where we have a user. So this is my friend Harsha Hampapura at NCAR, who has a Jupyter notebook. And within the Jupyter notebook, he uses the Python Pelican client. And he wants to produce a graph that uses 2 different objects that are accessible through the OSDF. One object's at NCAR, that's the black star on the left, and the one object's on the AWS Open Data Program, which is the red star on the right. So he knows the names for those objects within each of those particular pieces of data, or the respective object stores. And here I overlay the different pieces of the OSDF that we'll use to actually deliver the data. So we give each of the pieces of data or each of the object stores a location within our namespace. So we keep maybe the same object name, but everybody gets a different prefix depending on where that data is coming from, whether it's in car or in this case, AWS Open Data and US West 2. So Harsha has to take those names and feed it into the Pelican client. And the Pelican client will reach out to the director, which manages the namespace, in order to find the best cache to request or to get those objects for him. So the request goes out to the cache, which similarly has to determine the best place to find those objects where what origin services can deliver them. And here, because it was a cache miss, the cache goes out to the origin, which retrieves the object from the in-car object store, sends it through the cache and into the Jupyter notebook. Now, as a side effect of this, the cache, as you might expect, is going to keep a copy of that black object again in the hopes that there'll be some sort of temporal reuse. And the same sort of thing happens with Amazon AWS data. And Harsha takes those two objects, puts them together. And in this particular case, if I remember right, the AWS data is historical data, where the NCAR one was future simulations, combines them together in the graph for this particular science. All right. So what value does the OSDF provide to a CCPI? Well, first, I would ask, don't think of us as just some FTP server in the cloud or some cheap S3 instance. We're not going to shine when it comes to just storing bytes and treating us as a FTP server. So how does the community use this effectively? Uh, so, things that I think about us and our ability to stream data for your community at scale. So that maybe saves your project money, literally, if you pay egress fees on AWS. We can help you implement your authorization policy, and hopefully you don't have to come up with your own framework and spend project time doing that. One thing that we're doing more and always get asked about, particularly folks managing NSF data sets, who uses this? Who is my community? Can you provide us quantitative metrics? So we're do some basic stuff, and we want to increasingly hear what you folks are interested in, how we can save you time there. And again, we can help users to utilize NSF provided compute capacity and grow your community. One thing to note is if you're really squeezed for space, we can, through a partner project, the OS store that we run, host a copy of the data set on the OS store, actually using storage funded through the CC Star program. But that's another discussion we're always happy to have. So, what have a couple folks have done with this? One case, maybe one of our big headline cases, is NCAR. They have a S3 instance in Cheyenne, Wyoming, with petabytes of particular data sets that they want to share with the public. So no access control. This actually gets crawled by Googlebot all the time. But one of the things they want to start doing is help shift the mental image of their community from download petabytes and then I compute on it to streaming to compute. So more of that Netflix type usage. So we deployed an origin service for them. That origin service points at NCAR's on-prem S3 interface. So this is not AWS. All the data in their bucket is exported to OSDF via that origin. And then for their online web presence, they have a portal that they use where their community can find data sets, download what they're interested in. All their links now, instead of pointing to their S3 directly, have been updated so the HTTP download links point to the OSDF instead. So whenever somebody clicks on a link there, they're actually pulling it through one of our caches. And to help bootstrap their community about shifting their mindset to streaming, they've been providing sample Jupyter notebooks and change it to use the Pelican Python client instead of assuming a local POSIX access to their data. And now they say, nothing else, their collaborators in Korea are a lot happier because the copies of the data that they're pulling in Korea are coming from the cache that's within the country instead of streaming it from Cheyenne, Wyoming. So this is a little bit of what that example looks like, just in architecturally. And one thing to note, we did deploy the Origin and their Science DMZ on campus in their data center. That doesn't necessarily need to be on campus. Through the NRP, we can also leverage or put the particular service at the point of presence in Internet 2. One thing that's going to come up while we're on the top of S3 is we're actually making it so we can attach some storage to the origins. And then that way, particularly for those paying egress costs on S3, we can make one copy at the origin and then serve and feed the caches from there. That way, data really only egresses once, and we can hopefully save your project money. In that case, this would be the corresponding architectural diagram. Second case, one of our collaborators, Ramazan, is at Kennesaw State University, and he has one particular data set. He calls it Flamingo Sem. I don't understand what it is. He has it located on a shared file system, and he wants to share that out with just a few of his collaborators, not the whole world. So again, we deployed the origin service for him. This, because it's on a shared file system, had to be on a host where the file system was mounted. Um, we configured the origin to only authorize specific collaborators. And then through their single sign-on and through CI logon, authentication can be done with whatever the collaborator's home institution is. And then CI logon makes sure that the trust is established across the system. So that way, Ramazan hands his collaborators names of objects or things in the Flamingo Sim data set and says, hey, you can run this particular command line client. It might redirect you to a browser to authenticate, but you can use that to access the data. So in this case, not everybody can access it, but they can at least conveniently leverage their home institution single sign-on to get the data instead of having yet another username and password, which we all know is not the most popular thing. And one thing that we've been doing for newer deployments, besides this one I mentioned at Kennesaw, is CI logon through a service that we use in CI logon. We allow PIs to now self-manage their groups and they can add and remove the collaborators as they want. Those are just two simple examples. I can go at length and keep you guys very bored and here for a very long time of all the different possible things that can do. But I'd say if there's interest or some flavor or spin on this, we'd love to talk. There's also capabilities in terms of integrating with web portals. If you're a larger project that has your own web portal or automations for long-term workflows. I mentioned we have Python client, command line client, but under the hood, all of this is just HTTPS in the end. And it can be as simple as the in-car case where you just provide a HTTPS URL. So I always say the simplest OSDF client is just your browser. So those are how the integrations were done, a couple places how people use them. So one thing that gets us really excited is one of our other services is a distributed high throughput computing service called the OS Pool. Uh, and this is actually a set of computing capacity that we run across just short of 100 different institutions in the US. So if anybody doesn't see a star in their institution and wants to push us over to number 100, we'd love it. Since we have a distributed computing system, it meshes very well with a distributed data delivery system. So a typical day, 600K to a million jobs might take inputs from the OSDF. And in particular, about 150 different projects over the last year have used the OSDF to deliver inputs straight to their computation. So if you think that your community would benefit from scale of data delivery, you can give them the gift of computing and that particular data access to your data set. People use OSDF to visualize data. So we provide a Python client that plugs into multiple common libraries. I think pandas, Xarray, ZAR within the Python data science community, if you will. Uh, allows individuals to stream data through, say, a Jupyter notebook or a Jupyter hub, and you can start thinking about higher level services to provide for your community. And then finally, people can just use this to download and reduce the load of downloading through your site. And this is exactly what NCAR does for their research data archive service. And you can see here, I still have to maybe pay them some more money to put up a better logo, but they've recently changed all their web links over to use the OSDF. All right, what next? Um, I did not know some of the route views people were here, but I always like to use them as great examples. If you want to see the kinds of data that are sitting around on the OSDF, we have this page here on the OSG Consortium's website that highlights a handful or a couple dozen of the different integrations and data sets that can be accessed through the OSDF. If you're curious about using the client or seeing a couple sample objects and try it out. I did double check as of this morning. We have only 2 hours behind the reference copy of the route views data set. And again, and this is why I'm going to shift next to Ilke, there's much to do beyond data set delivery. What about building out examples for your community and things like Jupyter notebooks? How do you catalog? Here, our responsibility starts once you know the object name. How do you know what objects or what pieces of data you're interested in? How do you manage metadata attached to data? How do you maybe have it provide a runtime environment to teach classes or tutorials? So I'm going to shift off in a second here to Ilke to talk about the national data platform that does some of these things. Uh, but before I do, again, I wanted to emphasize for us, we think our science gets better when we are building communities. And we think that the communities are essential to what we do and that we advance through translational computer science. So working with you is how we get our research done. So we're interested in questions you have, things that might strike you the next day or that you forgot to ask. We love your feedback and let's work together. We set up a quick little one-pager type website for CC awardees. We'll put it there and we'll send out the slides afterward, put them on the website, and I'll drop it into the Zoom chat in a second. And we always love to hear from you over email, Slack, telephone calls, send us a letter. Let us know how we can partner with you guys. Thanks. Any questions?
Well, so I'll throw out one or two. But so I think this is really good. This really good, interesting stuff. So it's pretty easy to engage, right? I mean, it's and you've got the the letter out there. We've got these slides will be available, the recording. From an NSF perspective, I think this takes the awardee a long way to kind of meeting that goal of we want to get the data out there widely with a number of, and Brian's walked through a bunch of really good use cases. So, you know, I think this is something we'd really like to see. I know that from the awardees here, I think there's a pretty wide variety. I think some of you have data sets that we would really like to see kind of pushed out into these kind of environments. And so if you have a data set, if you're going to have a data set in your annual report or one of your deliverables, Kevin and I are going to give you a hard time about like, okay, how is the data set truly available? Are you caching it somewhere? Are you, do you have an access control policy? What's the, this is this can be a great answer. We're not mandating that, but we are mandating something. And here's a really good option. There's another group, and then I'll shut, and then I'll pass Brian back in a second. Yeah. So some of you actually, whether in this project or other projects, can be data consumers, right? And if you're not already aware of these kind of things, I think this is a great thing to look at and see, does this help you with other projects or a future NSF proposal? And I know we've got a wide range from sort of research institutes to to folks that might be a little more focused on teaching. I think there's a lot of good resources in here for integration into where classrooms and projects use data. So we felt this was worth everybody's time, and we still got more to go with NDP and LK, right? But I don't know. Is that for the PIs? Is that making sense? Is this any challenges you guys see? We're going to have more specialized discussions with smaller groups, but would be really interested to kind of hear the impression from the PI side. We'll have a chat. Yeah, go ahead, Brian. Yeah.
Well, I was gonna say, I know it's imposing to think of all of it, so we'd love to hear from folks even afterwards. And I would add, don't wait until you have the data to start thinking about this. We'd love to start the chat and start the discussion really early on, as early as you can, because sometimes these things take a bit to think through, right? A good quality integration doesn't happen in a day, so don't feel like you have to wait. We love to, even if it's just understanding what your requirements are going to be, we'd love to engage in that early, to make sure we're ready and we can provide as much value as we can. One of the wonderful things about being an active NSF project is if there's something that we do that doesn't meet your needs, we can work together and change and adapt.
Dan, this is Julio Barr. I'll just make a comment, and just say thank you, because I think this is a great introduction about what resources are available for a program like CICI. The ecosystem is very rich, with OSDF, OS Pool, all the different projects that Brian mentioned. So I think it's a great opportunity for this program, and we're really excited to leverage these resources.
Brian, one topic that came up in the chat is metric that will be useful for the data providers. I wonder whether any of the PIs have a wish list of, we would like to know this about our data.
This is Casey. I can speak up if you can hear me. I'm not in a great network location. Thank you very much for that talk. It was awesome. Every time I hear about OSDF, there's new things to make it better. But to that point, it was just made, that has been a sticking point for us since we started hearing, is that we're under a lot of pressure to report back usage statistics, who's using our data, which data are they using, how much are they downloading, and indeed, what are they using it for? So that also helps us not just to report to the agency about what's the best data to invest in, but for us to help the researcher, because sometimes they're not using the data they should be using for the question they ask. So we do a little vetting in advance just to make sure they stay on track and they're not wasting their own time. So I know that the OSDF folks are thinking about this already, and Christina's been great as we try to get some of our data on there. But that's just a looming question that we're also wondering how we can help with. I was just talking to Hans from Route Views this morning. I think he's on the call, where they're talking about putting a proxy in front, which would be another approach to this authentication. It sounds like you already have, where you can authenticate specifically to get access to the data set. So that helps a lot. But the usage statistics might be another level, and I'm curious how OSDF is thinking about that now. I know your thinking is evolving quickly on this issue.
Yeah, in fact, we were talking with Dan on this. From
Yeah,
project
yeah,
on
2 days ago. Thanks.
Yeah. So we had a great conversation. So, for some things, like if it's data that required authentication, we can provide, maybe per person usage statistics and raw to aggregated data. I think some of the challenge is eventually going to be not flooding you with enormous volumes of data. So right now it tends to be much on the raw, non-aggregated side, but I can see lots of future conversations with Dan about how to best wrap that up for getting you the right knowledge and not just the data.
Yeah, I feel that as we develop it, we need to think about privacy and other related, even security questions, to make sure that we take them into account as we collect, store, share data that has identifiers that can be associated with individuals and organizations.
All right. On that note, it might be good to pivot to Ulke to talk about NDP and some other services that PIs can provide as part of their overall solution.